This lesson is lesson 3, total surface area of pyramids and cones, which is from the total surface area and volume topic. The learning goal for this one is to look into the total surface area of what pyramids and cones are. And the success criteria for this one is to solve problems involving surface area and volume, more focus on the surface area part, right-angled pyramids, right-angled cones, and related composite solids. Before we look into the different examples of this topic, I want to just have a little bit of a breakdown of how the formula works. Now, I'm not going to go too much in depth of how it's constructed, but I want to show you that this right here is our cone. Now, a cone is technically, if you want to get really technical, it's considered as something that has a base to it. And that base, whatever type of shape it is, whether it be a square or a rectangle or a circle, they all conform to one point at the top, which is called an apex. In this example here, this cone is made up of a circular base with lines that form to the top of the apex, which is called, that line that is called a slant. Okay. And we dictate this slant by the letter S. Now, obviously, R is to talk about the radius of the center of that circle to the edge of that circle. Now, if we were to get the total surface area, remember, total surface area is just getting the area of the faces of the outside, the surface of that shape. This can be broken down into two parts. There's obviously the circle that's on the bottom. If we were to cut that cone and roll it out, what we end up having is a circle, but it's actually a bigger circle than the initial one. It's a big circle, and when flattened out, it has this almost like this little section that's been cut out. If almost like we were to have a full circle here. Now that S, again, that slant is that length here, which is also here, that slant. And these are the two shapes that we need to get the area of. Now, we know the area of a circle is pi r squared, so this is where this area 1 comes from. And then this one here, all we need to do, and we're not going to go into the math behind this, so just strictly looking at the formula, is pi r s, or pi times r times s. R again being the radius and S being the slant. And this right here is just showing you the shorthand notation that you can do this. But this formula here, if you give me a cone and its radius has been given and the slant has been given, I can give you what the total surface area is by putting those two values into here. And that's all there is to it. And that's how a formula works. We want to get something, we use a formula to receive a result of some sort, given different factors that affect what the answer will be. In this case, radius and the slant. And we say a right angle cone or a right cone because there's a right angle that is between the radius and what's called the perpendicular height. We notice that when we talk about cones, technically I could draw a cone where the apex is here, and it kind of looks like almost like a slanted party hat of some sort. Because this angle here that's created is on a slant, it's not necessarily a right cone. It's not a right angle cone because that angle made in between here is not a right angle. So you just got to be careful of the type of cones you get. Obviously, all the questions will be based on this type of shaped cone. A pyramid, and to be very, very specific, a square-based pyramid. That's a polygon with the remaining faces meet up at the apex. Remember, the apex is that top of a point of a pyramid. With a square base, we have a square at the bottom with 4 triangles, side, front, side, and behind, that all meet up to this apex. And to get the total surface area of this, so this is actually quite simple because the total surface area is made up of 4 triangles. That's right, 4 squares, 4 triangles, and 1 square. And we know the formula to get areas of a triangle and a square. All we need for a triangle is a base and the height, and all we need for the square is the length, which is actually the same as the base of that triangle in the first place. So to get the formula for this one, so the total surface area of a pyramid, and every time I write pyramid, just assume that I'm talking about a square base pyramid, because you can get different base type of pyramids. Total surface area as a pyramid is L squared, and L squared being the area of the square. Give me the length of the square. And we're just adding 4 lots, so put this in bracket, 4 lots of half times base times height, because this is the formula to get the area of a triangle. And these are the 4 lots of triangles. So again, with this formula, give me the length and give me the base, which is effectively the same as the length here, and give me the height. Give me those 3 pieces of, or 2 pieces of information. I can plug this into a formula, and then I can get the total surface area for that shape. Now we've got some insight to the formulas of a cone and a pyramid. Let's use it to help us with this example here. I'm going to find the total surface area of the solids using 2 decimal places for part A. So A, we're going to look for total surface area of a cone with a radius 2 and a slant height of 4.5, and that's the only 2 information that we need. And then we're going to look for the total surface area of a square base pyramid with the square base length of 25 mil and a triangular face height of 22 millimeters. So let's look at A first. Now A, if we head back to this formula here, we could just use this formula of pi r squared plus pi rs, there we go, in order to get the total surface area. So remember, this is our total surface area for a cone. And our radius is equal to 2 meters and our slant is equal to 4.5. Let's just plug this into the formula and see what we get. So pi times radius, so 2 squared, remember to square it, plus pi times 2, which is the radius again, times 4.5, which is the slant. So we'll grab our trusty calculator, clear everything that's there. To keep it safe, let's just put this into brackets. So bracket, remember shift and that times 10x to get your pi. So pi times 2 squared plus pi times 2 times 4.5. Now, if you hear beeping in the background, I'm currently recording this in my lounge room, and my PlayStation 4 has been having these weird problems lately where it just keeps beeping. It's quite annoying. So just deal with it, because I always have to deal with it. Okay, so 2 decimal places. This is 40.84. Remember, you just have to press the SD button if it shows up as 13 pi. 40.84. So 40.84 squared meters is the total surface area. In other words, considering how big this cone is, let's just say that this maybe is a tent of some sort, and it's made up of this fabric. We want to see how many 1 by 1 meter maybe fabric patches can fit within the surface of the cone part, both around and on the bottom, and approximately nearly 40.84 of these squares can fit on that. That's how I think of it for the total surface area. And B, the last example here for B, we're going to look for the total surface area. I'll scroll back up again. Here we go. A square base pyramid. So a square base pyramid. So this pyramid that looks something like that, with a square base length of 25 millimeters. So it's 25 mil, and also again 25 mil, and this will be 25 mil everywhere. So if we were to do this, be 25 mil around the side, and it has a face height of 22 mil. So from the apex down to where it hits the base at a 90-degree angle, that height is 22 mil. And now again, we've got all the formulas. So this length, this is the length of the square, is 25. The base is also 25 for one of the triangles, because this triangle, if we were to cut it out, will be 25 with the whatever the height is, and in this case 22. 22 mil, to be very specific. So this height is 22 millimeters. Now again, our formula is the TSA for this one. This is going to be equal to length squared plus 4 lots of half base times height. And it's just a matter of simply substituting in what we do know. Base is 25 and our height is 22. So all I've done was just taken everything that I know and plugged it into the set formula. And that's all you need to do in order to get the answer for this one. So let's do 25 squared plus open bracket or times. Now I'm actually going to put the fraction for this. Half, draw across, times 25 times 22. Close that bracket, execute that, and 1725 squared millimeters will be your answer for this one. So total surface area of cones and pyramids are quite simple because this is a set structure of formula that you just follow, provided that you have either the slants and the radius for a cone or the length, base, and height for a pyramid. Now before you tackle your questions, you'll notice that there is a question here within your log sheet of pyramids and cones that it requires you to do question 6 within here. Oops, I didn't mean to do that. Please don't do question 6. There won't be anything necessary for that within your test and within the end of year exam, assuming we're doing the end of year exam. So don't do 6, but if you do want to challenge yourself, you can attempt question 10 left hand side. And that's all there is to it for this exercise. Until then, I will see you in the next video. Bye bye.